Okay, so good morning again, and welcome to our presentation today on Plant 3D and Advanced Steel collaboration. My name is John Bennett, and I work for Graitec as a customer success manager and an application engineer. So a little bit about myself first. There's a picture of me there. Basically, I've been involved in structural fabrication engineering since I left sort of college, really. Very long time now. I won't tell you how long, but a long time. That sort of eventually led me to working for Graitec, and then obviously on working for Autodesk, and primarily with the software Advanced Steel. In recent years, though, I've sort of migrated to cross-platform integrations as well. Found myself in several situations where I've had to integrate Advanced Steel into different engineering environments from plant and Revit, all to do with the structural markets, which is hence why we're sort of doing today's presentation, is to try and give a little bit of background to people, a little bit of intro so they understand that Advanced Steel, although a standalone platform on its own, you can integrate it with one of those sort of its sister platforms, which in this case is Plant 3D today. So before we sort of get into that, I wanted to also mention this is one of a series of webinars that we're running by the UK team. So there'll be a series going on over the next week or so. Obviously, I'm kicking it off with the plant one today. There's another one this afternoon to do with our product, Advanced Design, Robot, and Revit and Advanced Steel sort of workflows and integrations, looking at things to do with that, how you can transfer your analytical model down into the Revit platform or the Advanced Steel platform, or go the other way. We have our MIS solution being demonstrated later in the week. And one that might be of interest to people today is that we're going to be sort of taking on a bit more about drawing customization for the plant industry. I'll be showing you a little bit of basic customization today in my demonstration, but my colleague Tommy will show you a little bit more on some of the projects that we've been working on in the sort of North American area, and obviously some of that information sort of transposes into the UK market because of the parent companies involved in that use the same sort of drawing customization or need the same requirements. Rob's going to be doing the Power Pack later on as well in the week on the 28th. That's our bolt-on for Advanced Steel. He's going to demonstrate some of the extra tools, some of the extra data sets that we've put into that as well. And then Rob's going to close it out with a Advanced Steel Revit integration, talking about the transfer between Revit and Advanced Steel, similar to what we're talking about today, but in the Revit platform, and looking at connections, etc. in that. So try and register for those, and if you can't get to them, at least then you'll get a link and stuff like that you can go and watch the video and stuff later on. So moving in today, so Plant Advanced Steel. So these products sort of do go together very well, and they do collaborate. There's a couple of different methods for doing this and a couple of different workflows. I tried to group it into two areas. Fundamentally, there's the first one, which is we call the transfer file, which is the SMLX file. It's an extension that's available, and it's actually available for Revit as well. And it uses some of that technology inside the plant as well. So inside the plant platform, there's a button which will export the data from plant to Advanced Steel. Another way of working also is collaborating using object enablers, etc. So we'll have a look at those as it goes along through today. And we'll look at some of the steel connections that you can use. So we can add the steel connections in Advanced Steel, some of the other steel tools, and sort of the transfer methods, collaboration methods, and hopefully I'll include a few tips along the way as to things that we've sort of found from our experimenting with these workflows. So a little bit about the SMLX, and to be honest, I've probably cribbed a little bit of this from a presentation I did last year for Revit. So the button is on the ribbon tab in Plant 3D. It's a nice big button, you can see what it is. And what it is, the SMLX file is, they call it steel markup language file format. So it's an extension that enables you to sort of transfer data from one model to the other, and it uses a database in the background basically, and a bunch of rules that are used to control how the objects are read from one software to the other, linking to sort of the parameters. So there's quite a bit of data gets created in the background inside the database tables, and obviously that depends on which country you're in as to how that works and how that integrates. Depends on obviously the plant content you're working with as well. Obviously, if you've created some of your own, you would probably need to speak to someone to get your own customizations done. It won't automatically appear in the system. So a little bit more into that, a little bit trying to explain a little bit more what's going on. So I tried to break it down into 2 or 3 slides here. So basically, it's rules for objects, the shape that's behind them. So each sort of reference shape, it has a reference shape, and this is broken down into a reference in the sort of source platform it's coming from to what it's being driven to, and that can be assimilated into like a string, a code, with the various parameters for the height and the width, etc. And normally the application is designated as well within the table. I mean, I've just done a little screenshot there, which I added into the slide to give you sort of flavor for what's actually in the table inside the database. Obviously, I would recommend that you don't probably go around in there and mess around inside it too much. Probably speak to someone to get a little bit of advice, a little bit of help before you do that kind of stuff. And to be honest, this is the kind of thing we end up getting involved in ourselves here. We end up going to sort this out for people, advising them on the best method to apply. A lot of this is coming, obviously, a lot of the data behind the SMLX is actually based upon the Revit interface. It's quite big in that, and there's been a lot of improvements. And basically inside the plant platform, they're using a cut down version of that. It literally is a one-directional. The one inside Revit's bi-directional. So this is a one-directional one, and what it does is it looks at the shape itself inside Plant 3D, and obviously you'll have common references for the height of the section, the thickness of the flange, the web, even the root radiuses, and things like that get then transferred across. And similarly, in Advanced Steel, we have a corresponding shape reference. So like the example image below is an I-beam, and these common parameters will get mapped into the string. So what the beam type is, we'll pick it up from its internal name, the depth of the section, the width of the flange, all these kind of parameters are written into a string and stored inside the rules table. So a little bit more about the mechanism. You can also do one-to-one mappings as well. This is where, if you know the name in one software and you know what it is in the other, you should be able to map it across. This can become quite useful. I mean, this is a slide actually that we did for Revit last year, where we highlighted the issue of a capital X and a lowercase x. And I know from experience in certain countries where I've been, this can cause a bit of a problem because people like to show the X as a capital, whereas it might have got written by the person who programmed it as a lowercase, and it can cause a problem mapping from one software to the other. So sometimes the one-to-one mapping can be a useful reference when you're trying to add things in, rather than trying to write a complicated formula. So there's another aspect as well also to the transfer. The SMLX file can be quite good for sending sort of quite basic structures across that someone's schemed out. For example, I'm going to talk about a pipe rack because that's what I'm going to show later on. But another element of the software enables the object enablers. So being as Advanced Steel and Plant 3D are AutoCAD-based programs, they both have their own series of object enablers. They've been around for Advanced Steel, I think 2016 it came in, so I've only gone back to 17 at the moment. But what you can do is, if you're working within a company, you can actually use the object enabler. So maybe you've got a limited number of licenses, someone's a specialist in Advanced Steel, another detailer is a specialist in plant, but the two guys want to work together, they want to see each other's details. So obviously installing the appropriate object enabler on the corresponding machine will actually facilitate that. I found recently they don't tend to install the object enablers automatically now when you install the parent software anyway. So you need to go and download those, the sort of blue text at the bottom of the screen, which should be in the handout as well, which is attached today. We'll give you a hyperlink to go and find those. I think I did it for the 19 version, but if you just type in, you'll get whichever version you're working in. 17, 18 and 19 are the current available ones that I could find when I looked the other day. So this is quite an interesting way of working, because sometimes, and me personally, I like to use some of the other tools inside Advanced Steels for drawing stairs and railings, for example, and I really don't want to bring all the original steelwork via the SMLX, but I want to use that as a reference for me to actually model around, because I might need to adapt the stair or the railings or even the platform level, because of the basic scheme is not what I would do as a detailer from a steelwork point of view. Someone from who's doing the piping and the equipment has just put something generic in place to show a representation. So with this, you can see what they're indicating, but then you can configure your own thing and just turn on and off the X reference or however you want to configure it to see what you need. And it also enables you to work together to do collaborative drawing outputs in each platform. Okay, so so basically we're going to show a little bit of working with the OEs. I'm going to try and do the SMLX as well today. So I'm going to look at an overview of each of the platforms, try and do something to explain the basic tool interface and tools, and obviously show a little bit of collaboration. I'll try and get to a drawing on each one. I do have some stuff prepped. Obviously, if I'm sort of running out of time, there's a lot to cover today. So I'm going to sort of move into that in a minute. But basically what we're doing is we're taking stuff from Plant 3D and we're going to collaborate it together, and then we're going to take it out and we're going to bring an Advanced Steel model in, and we're going to bring it all into the same plant environment. So with that, I'm going to sort of switch over to a live presentation and show you the interface between the various tool sets. So this is my plant platform here. So for those of you familiar, obviously Plant is based upon AutoCAD. It comes as a true vertical now. You can obviously create all your equipment and models in here. It is an entire project, and my personal experience when I've worked with several companies in the US on this, we found that obviously the steelwork is a subordinate element to the main project. So it becomes an element that's built within the plant structure itself. And there's obviously an element of being an X reference file, and they seem to sort of collaborate these together within inside the plant environment. So it was quite important to find a way to try and integrate Advanced Steel to that, because Advanced Steel is its own standalone platform, its own standalone detailing platform, and its own documentation system as well. And there was a few problems with this. We found people were copying stuff, because you can copy a model into Plant, and this is leading to duplication and that. And then with a little bit of sort of lateral thinking, we thought about this and we came up with a few ideas of how to work in the best way here. So you'll see a folder. The file I've actually got open is this actual file here, down here, which is just this is a normal plant file with an X reference for the concrete. These are some steel elements that have been drawn in. You can see the beams just been schematically drawn all the way across at the level. And obviously this could be transferred out, first of all, to an Advanced Steel project so we can import it. So what I would do first of all is I would try and set up something to make sure that my Advanced Steel elements were part of the plant project. So under the 3D part of this, the source file tab here, under the 3D, I've created a little folder in here. And what I did is when I created the folder, I'm actually going to embed my Advanced Steel model inside my plant project. So this is the folder name here, and the important thing that I did here was actually to ensure, because I want an Advanced Steel template and I want it to work with all my tools inside Advanced Steel, the way we assign layers, connections, etc., I need to start with an Advanced Steel template. So in this case, I would actually go and map it to the appropriate location inside Advanced Steel. So here, I know where this is because obviously I'm familiar with it, but obviously other people can go and find this as well. We do tend to sort of show people where this is because these are the kind of things that we would end up helping people to configure. So here you would look here and you'll see a template. There's several of them here. I created some extra ones when I've been doing some experimentation, but normally you just come to this basic template here. And this is the one that you would select as the template for the file so that when you went to create a model, it creates it from an advanced steel template. So what I'm going to do is I'm going to create a new drawing today, and I'm going to call it, just give it a message here. Just put that in so that I can figure out what's going on. 21/01/19. Apologies if you're watching from the US. That's the way we write the date in the UK. So obviously you give it a name. You can obviously change. You can make this if you obviously have a naming convention. Obviously you would probably do something different to that, but you would just do that, and it will go off and it will create that file, and it will add it into the plant project. So we can see the files open here on the system. So this is an advanced steel template, and I've opened it inside plant. It's actually inbuilt into the plant project. And I know it's an advanced steel template because I can see from the layer structure that that's what I want. So I'm not going to do anything else with that file at the moment. I'm just going to close that file. So I'm going to come back to this particular model here. And I'm actually going to go to the structures tab now. And I'm going to show the advanced steel export here. This is the XML button. It's on the structures tab here. So you would press this and it will bring up a dialog. So what you need to do is you need to select the objects. So you can do that with a crossing window, or you can do an individual selection if you just want to select a beam. And then I'll just do a little bit of left and right click. And then obviously I need to go and store it somewhere. So this is the output file. Now probably what I will do is I'll probably give it a sort of name that I would recognize. So today I'm going to put some initials in front of it. Just going to call it something I recognize. So you can call it any name you like. Obviously, if it's job specific, you would do that. The important thing is to make sure that you store them somewhere. And obviously, I created a folder under my plant project itself, so I knew where they were. Even though it doesn't probably show up inside the plant project, I actually created that file so that I didn't have to go off and look for them somewhere else. So then I press the export button. Once I've got the object selected, I've got the destination file. We can see down in the bottom right here, it should process that. See the little blue bar going across there. So that has sent out the elements from plant. And now if I was to swap to advanced steel, so I'm just going to go to this model here. So this is the advanced steel platform. Now, to be honest, you can see this is actually a finished article in case we didn't get around to doing it today or we had any problems. In the best interest, obviously, better to have something prepared. But fundamentally, this is the same pipe rack that I exported, and I went in and I added a bunch of connections to it and joints. So this is advanced steel. This is how it works. This is all the standard joint details. So if you were to put a connection on, you can actually look at its properties and it'll apply all the cleats, etc. to it. So these are the typical dialogues in advanced steel that you would see. Obviously, you would need to be trained in how to use this to understand the connections and the joints and how to model within advanced steel itself. Now, what we can do is obviously we can open the file that we just saw. So this was the file that I created inside the plant template. So remember, I created a new drawing inside there. So I'm going to open that file, and like Plant 3D, Advanced Steel is based upon AutoCAD. It uses a ribbon-based technology, and it has very similar commands. Not exactly the same, but it has a similar command. So we would come here to an import button, and we'll go and pick the file that we created. So this was the file that I created just now, and I'll just go open. You'll see the same progress bar appear down the bottom there. It's quite quick when it came in. So you can see that now the file has been transferred into Advanced Steel. Now, in this instance, obviously it's brought the file in, it's brought all the beams in, all the beams are continuous across here. So obviously if you're a steelwork detailer, you're not going to do that. You're going to want to split it up and things like that. So this is where you could take this file and you could start using the tools inside Advanced Steel. So here, this is the split beam command. And we sort of use the same sort of things. We use node snaps or endpoint snaps. So the normal snap settings that you see in AutoCAD, you can use. You can use basic AutoCAD tools as well as advanced steel tools inside the system. So I mean, it's quite easy to do, and you can see there it's cut the beam now into two. And obviously I did all those. I sort of split all those up all at once because I selected all the beams before I did it. So this is where you would sort of start, and then you would sort of pick connections, etc. So if you wanted to put a base plate on, something like that, or you wanted to put a clip angle on, you would come in here and you'd pick a joint. So here, this is a clip angle joint. So depending on how it's set up, which country you're in, it will have its own parameters set installed inside a library. So it'll apply a clip connection. There's tools inside Advanced Steel. Also, for copying joints, you can do a singular copy. So this is a singular copy of a joint. So again, you follow the prompts that come up, and you can put it on, and you can keep on putting it singularly. You can put it in as a multiple. So if you wanted to do, say, the same thing down here at this end, you could pick the two columns as the two inputs and the two beams, and it'll apply the joints as well to that. There's different variations of the joints depending on the configuration of the steel. Obviously, if you've got two beams together, you'd have double clip angles. Obviously, if you've got a base plate, you've got a base plate joint on it as well. So you'd pick that, so that'll be a different type of joint. And just follow the prompts depending on what you want to do. And it should look at a library, and it should put a connection on. If you want to change the variable, the connection, you can double click on the grey box here, and it should just come out. And you can come in and you just come in and you can change anything you want here. So this is the base plate thickness. So for example, if you wanted to change the value of the shortening, if you want it to go up or down, you can adjust how it moves. So this can be put in to make a pack allowance. You can put packer plates underneath it. There's all kinds of different variables in here. I'm not going to go and show you all that today because it will just take too long, and you really want to watch an Advanced Steel demonstration for that. But fundamentally, that's what you can do. You can also then use, obviously, X-reference tools as well. So we can attach a DWG. So if we want to bring in the concrete base, we can do that as well. And we can see that that's the concrete base. So this is the concrete base from the from the plant 3D project, not the Advanced Steel project. So this is where we're collaborating now between the two platforms. We can see the interface there. We can get an idea of what we need to work with. So just to sort of show that, if I just save that file, so that started off as a clean file inside Advanced Steel, I'm actually going to close that file, and now I'm actually going to come back to my plant. So if I go back to it, you can see that there's the file that I created this morning. And obviously we just had that open inside Advanced Steel, and now you can see that I can open it inside Plant 3D. And you can see, I can see the details here. I can't actually do anything with this. It's just, it tells me it's an Advanced Steel beam. It has all the properties associated with it. Obviously you would need Advanced Steel to edit anything here. But this is typically where the discipline comes in within a company. You have specialists that work in certain areas that do this kind of work. Or it might even be passed down to a third party, an external detailer, etc. So the idea is that you can transfer the information at a very sort of rudimentary level. They can utilize that, and they can start working with it. And then the way to see it back the other way is to combine it into your plant project and build it and store it under your plant project itself. So obviously we did a little bit more work on that. So inside Advanced Steel itself. So that was this model here. So I'm just going to go back and show you. So I obviously went in and I added all the different connections onto that model. And to be honest, it took about 10 minutes to do that, you know. And then obviously I've used Advanced Steel to obviously create a drawing. And in Advanced Steel, we have a slightly different method of creating drawings for these elements. So we used a camera, which was the blue object that I just picked. And this will produce a drawing. So again, I'm trying to use the obviously the plant object that's underneath. I'm obviously governed by how the plant object presents inside Advanced Steel, but I can obviously see the high level of detail. And depending on what connections I've added in, sometimes you get beams that don't show properly because I know you can see these haven't got connections added to them when I've done them. So that's typically when you get that, people phone us up all the time about it and says, why doesn't that work? Well, that's because there's connection missing. It can't work out what the line is there. So I thought I'd show that because not everybody realizes they think it's doing something wrong, and it's not actually doing anything wrong. It's just it can't work out how to draw the lines. If you put the joint on properly, it will draw everything out correctly. So that's sort of the primary method that I would use for transferring quite a bit of information that was fairly basic and maybe didn't need a lot of coordination between the two platforms. It was just a basic structure that needed to go in and out. But sometimes you get things that are a little bit more complex. So just coming back into my plant platform here. So obviously here we can see a model here that's in front of us here. Now this model is obviously using, this is an equipment X reference from plant. So I'm back inside Plant 3D. I'm back inside my folder here. This is actually an advanced steel model I've got in here. And these are actually advanced steel elements here. So again, these are columns and beams that I've actually used to create this and obviously work out where I need to put supports in, etc. And I've gone through and put all the different connections on. So this is where I'm sort of working between the two elements here. Now, if I was to go back and show you what that actually looks like when it starts, inside here, there'll be a folder here. So there's a here. This is the original X reference that it came from. So that's the original X reference there. And so we've obviously linked that into the model. And then there's obviously you've got the concrete one, which is another X reference, which is the base detail. Okay, and then here you can have and this is the primary X reference for the steelwork as it was laid out inside Plant 3D. So this is the example where someone's actually modeled this as a schematic inside Plant 3D to give the detailer an idea of what is required. Now, obviously, you know, if you're doing this from a detail point of view, if I was to look at that in advanced steel, I would probably think, okay, well, I'd do the stair using a macro, I'd use a railing. So I don't really want to send all this out. And to be honest, I'm probably going to have to put a bunch of extra steel work in to do what I need. So in that case, what I actually did is I took the file, and again, I created a new file here inside Plant 3D. It's an advanced steel file. I then opened that file inside my advanced steel platform. I X-referenced in the bits that I needed, and rather than actually exporting the steel, I actually just used the X-reference and I mapped over the top of it for the primary locations. But for the secondary locations and the staircase and that, I did it as a series of macros. So you can, I'll leave that drawing open on the screen, and there's a corresponding drawing below it here, which is a similar sort of thing, and I'm just going to show you that inside Plant 3D. Obviously, the reason I do that is because it's locked inside. If it's open inside Plant, this file, it's locked when you try and open it in the other file. So you have to have one closed and one open. So if we just go back to advanced steel a minute, so I'm just going to come back to a file here, and if I go open again, so I'm actually inside the plant project itself. I can see the drawings that I need. I can open them in here. So we just give it a second to pull it in. So at the moment, I don't have any X references attached to this. Okay, so you can actually see how it sort of finished up. This is how it sort of finished up. It finished up with all this extra steelwork in it from when I started. But what I actually did was I actually used the X references in here, and I just attached the various corresponding ones that I needed. So here, this was the ladder vessel. So obviously I opened that and I attached it to the file so I could use it as a reference. And then also I did exactly the same thing with this one. So I just come in here, attach the reference, and I go up a level. And I'm just going to attach the basic thing. Whoops, sorry, I went to the wrong one there. That's because it's been open in the previous version. So what you would do is you would bring that in, and then all I did is I just mapped over the top. But the reason I mapped over the top is that here this is actually a macro. So inside Advanced Steel, this is actually a joint. So the stair is not drawn as individual beams and treads, etc. It's actually drawn as the macro here. So this is a tool inside Advanced Steel where you can actually store properties for a staircase. So if you always draw your stairs the same way, the same type of stringer, the same type of tread, you can create library entries, or you can start from scratch each time. And you would create these in here, and you would put obviously the various different types of treads. It has different. So this one's just a plain sort of grating tread, type 1 with an end plate. And depending on what database you're in or where you're working, you'll be able to access that and change whatever you want in here. I mean, US has a standard grating, Europe has a standard grating, but you can add manufacturers in. You can configure the handrail. So the handrail is a macro as well. So this kind of stuff we do in these tools inside Advanced Steel. We don't tend to model these as individual elements. They're like a parametric joint, which you can then adjust and store inside the system. So if you're always going to be doing the same type of stair on a particular type of project, you only got to create one of those. So the similar sort of thing here with the railing. So here, this is obviously a joint as well. So again, I didn't want to bring all this in as individual elements because I actually want to just recreate this as my macro. Excuse me. Inside Advanced Steel. And this, I mean, obviously to learn how to use these kind of things, you would need to come on a training course, or I would advise that you come on a training course. Don't just try and go and do this off yourself. It can be quite complex. It takes about 4 days to learn Advanced Steel, to get the basics anyway, and obviously quite a bit of practice with it. Now, there's other joints in here. There's obviously these are little joints here for the bracing. Okay, so again, you can look at the joint properties, and it will apply all this. So all this steel work that I've applied, if you was to actually go and look at that, you know, back in plants, so if we go back and look at this model here, so this model didn't have any of that in it. So I've gone in and I've added all the supporting structure that's required for the decking where it sort of needs to interface with the other two. Obviously, I've worked out what the gallows bracket cantilever assembly here. Obviously, the hand railing didn't really configure with what I wanted. I even had to change the position of the stair. I had to provide some additional steel work to support the stair. So if you look at with the model here, you can see I'm still back in plant now, and I'm still seeing my Advanced Steel model back in here via courtesy of the object enabler installed. So it enables me to see both together. Now I've had to put all the supporting steelwork in. I've actually had to alter the level of this. I've had to obviously configure this to pick up on the pipe support here. I've also had to, obviously I was working on putting some cantilevered structure around here to give some sort of support around here. I'm trying to figure out how to get it to fit around here so it supports the decking. Obviously I can see it's going to clash with a couple of other things as well. So you would work together, you would collaborate with the two different platforms. Now in that instance, like I said, I just used the file as a reference. So I used this X reference here and the other one to create what I wanted. So I didn't use the SMLX file to export it, but I just worked with it. And the important thing is that I put it inside a plant project as well. So it was linked to that project. It's actually stored inside that file structure. So when you create a plant project, obviously it has different folders get set up. Now this can be configured inside Plant 3D. People do this differently depending on which company it is. There's all kinds of tricks. I'm not a plant expert. I just learned how to try and work and interact with it. I defer to other people who are plant experts. But obviously you can see where we've added in the various folders here, and you can see the models, and even everything just keeps getting added in. Okay, so and then you would start adding in, and then you can see things coming as well here. This is actually because I've got the file open, Advanced Steel will create its own folder to store its drawings in, etc. So you can actually run drawings from the model. So it's quite important to structure what you want. I mean, that probably needs a little bit of communication between the various departments on how to do that. So when you're in Plant 3D as well, obviously there'll probably be a requirement to do a drawing. Now, my personal view is that Plant is really good at doing plant, and obviously Advanced Steel is really good at doing steel. A slight crossover between the two. I would try and do the final structural drawings for the steelwork inside Advanced Steel, but I would do the plant drawings for the plant stuff inside Plant, and I might need to show the steel and the plant combined together. So in this case, you would probably want to go and obviously create a new drawing, etc. So here, if we're in a model, you can actually go and create an ortho view. So you could add this to an existing file, or you can create a new one. So depending on which tab you're in. So here, obviously under here, I mean, you can see I already created something for the pipe rack this morning. So this was this file that I had open this morning. So when I was doing this, I actually created this drawing just as an experiment to see what I could get out of the system. So what we can do is we can go back and we can create a new drawing if we so wish. And we can pick the models that we want to do it from. Okay, so if I go here and I'm going to go create new, so I'm just going to give it a reference here. So again, obviously you can control all your project paths, where you want to store it, which template you want to use, etc., etc. So if you have particular templates you want to do in Plant, you can use that. And to be honest, you can probably create the corresponding template inside Advanced Steel. We call it a prototype file, but you can fundamentally make both softwares look very, very similar, if not identical, depending on the attributes that you're using in the title blocks, etc. So here I'm obviously creating a new drawing here. So obviously Plant works slightly different to Advanced Steel in the way that you create a drawing. So, but it's a similar method, basically using a box to define what you wish to see. You can snap to points, etc. So here I'm just trying to reduce down the size of the box, so that I can see what I want. Now, depending on what I want to see, obviously I can let it do all of it, part of it, etc. And I'd probably just go OK to that, and then we'll place it on the piece of paper. Oops, didn't like that. And in the best ways that happen when you're doing a demonstration, it doesn't work. Oh well. Only ever happens when you're doing a webinar. Let me go back and see if I can get back into that. While that's waiting, I'll go back to Advanced Steel. I'll wait for that to reboot. So I'll come back to the Plant bit in a minute. Apologies for that. So Advanced Steel, it has a similar thing for creating a drawing. It uses a camera object. Depending on how you set it up, how you configure it, it will actually be used to produce a drawing from that. So we have a similar thing. We have a palette that we actually do our drawings on. It's actually the drawing process here. So what you can do is you can pick these particular elements, you place them inside Advanced Steel. You can see these blue objects that are placed around the model. And depending on what you want to do, you can have different types. And different types can be used to drive different outputs. These elements can be customized into creating a different series of drawing styles and drawing processes to produce particular types of drawings. So depending on what you're trying to do, Like example, I already have a drawing here that might be created. So, I mean, I can go and have a look at it, and it'll show me what's in the model. It'll tell me if it's out of date. It's actually telling me it's out of date because I unloaded the X reference and probably reloaded it. So what you can do is you can pick an individual one. You can then press a button and it should process this. So that actually created a drawing. I can tell that from the command line down there, 300051. So I can actually go and look at that. Obviously, you can see that I've been in here experimenting with this in the last couple of days. So I just recreated that drawing there. And basically, it depends on how you want to do this. You can, so if you want to do an isometric view, you can select that as well and do that. So what it does, it scans the model, and it depends upon the content of the drawing that is required, and that's what we call a style in advanced steel. So how it's labeled, how it's shown, what's shown, if it shows X references, if it doesn't show X references, things like that. So you can do different kinds of things depending on what you want to show. So I know that's drawing 52. So in this place, I'm obviously showing the plant objects as well. There's a little bit of limitation on the presentation of the plant objects, which is why I said you should try and show the plant objects and the steel objects inside Plant 3D itself rather than inside Advanced Steel. Advanced Steel is probably okay for the steel work, but probably not for the other one. And there's other tools as well. This is actually a customized palette. So this is part of the thing that Tommy would speak about later in the week, where we would customize the palette to actually show different things or do different things. And this is normally customer driven or sort of or end user driven. So it depends what the end user's CAD standard is onto how we configure this. So the details behind the configuration are controlled in the drawing process manager. We have lots of stuff in here that we go in and configure, pointing it to different styles, creating steps and processes to actually create these outputs. So this is part of what Tommy will probably speak about later in the week. I just did a very basic customization here to show the output and just give a little bit more of a flavor. And another element that we sometimes use, depending on what people want to do, you can set it up so that you can actually just press a button and actually get it to process a bunch of drawings. So actually all the cameras that are in the model now will be processed. And those will be processed in a sequence. I tend to find that people do drawings in a sequence from Advanced Steel. So they'll do plans, elevation, sections, local details, and they might start with isometric views. So this will actually process all these blue objects that are in the model. Now, what I tend to do is put those in and set them up as I go around the model. So I'm just going to leave that. It's just obviously running. You can tell it's processing at the bottom, and it does take a few minutes to do that. But it will create a series of drawings. It doesn't just create one drawing. So we're on 52. I expect it to finish up about 60 something. And this is all using all the stuff that's been configured in the background. So this is the beauty of Advanced Steel. You can configure a hell of a lot of it and customize it. There are a few limitations. It's not perfect. It doesn't do absolutely everything the way everybody wants it. But from a steelwork point of view, it's probably quite good. I found it quite good anyway, from my opinion. I'm just going to, while that's going, I'm just going to flip back here and go back to my plant project. I'm just going to try and get back into where I was just now. So let me just go there. Just check and get that open. It's okay, so that's open on the other machine, so that's right. So let's just go back to Advanced Steel. So we can just see here that it's listed a bunch of joints, so 3061. So what it would have done, also inside Advanced Steel, there's a document management system. So I'm just going to access that. So the drawings I actually created was probably started at 5.3. I can see a little preview in here. And so it ran all these drawings right the way through. So this is a series of drawings it would have created, and it depends on what the criteria. So obviously that was a base plan, so a foundation plan. So you can open the drawing from here, you can open it from the camera, you can obviously add dimensions. There's an editing tool here. So this is where this bit here, we add the parametric dimensions in, etc., labeling, etc. And a lot of it, what we try and do is try and configure this so that it just comes in as it is. You don't have to do anything to it, but you have this labels and dimensions thing where you can add dimensions in. You can pick a point, and it uses snap points to snap to. So make sure you try and get the correct one, and you just put it in, and then it will just do a chain of dimensions. And it doesn't matter if you happen to put the chain in the wrong place. Okay, you can come in and you can pick it up and you can move it afterwards. So depending on where you want. And this has tools. I mean, a lot of people miss this, but this is all covered on it. So if you don't want all the dimension points, you can just go back in and edit it using the delete dimension point. And obviously similarly, there's one to insert dimension points as well. So if you want to pick a point, you can add one back in, and you just grab a grip and move it to wherever you require it to be. So I was trying to do the drawing in here. Obviously it didn't like me this morning. So I'm going to show you. This is a drawing that I did yesterday actually. I was trying to do today, I think, and this one. So this is where I've been sort of experimenting with it. So obviously, depending on what the view is, you can adjust it in here. And this is one of a stair, I think, here. So we've done this before, so I can open that there. So, and obviously these are adjustable inside Plant. So depending on what you want to do, you can adjust it to see things. And the point I'm trying to show here is you can actually get quite a high level of detail by combining the models back together, back into the plant environment. At the moment, I would say some of the labeling is probably a little bit limited inside Plant 3D, but it's more about the plant objects and showing the combines the stuff together. So, like I said, I would do plant objects inside Plant, and advanced steel objects, I would probably do them in the advanced steel drawings, but just try and show the two elements together. Just going to come back here because obviously I've got this drawing open here. I just want to close that. So these are just DWG files. These can be viewed by people who have the object enabler as well. You don't need to explode them. So if you're working with someone inside the company, it's probably best to actually deploy the object enabler for Advanced Steel across your network of machines so that anybody can see the data. I do believe the stuff can be uploaded to BIM 360, but I think I'm not sure what platform they're currently using in Plant at the moment because it sort of changed. I think it was Team. I think it's going to Docs, but I'm not really sure. Tried to ask a couple of people, couldn't get a straight answer. So let me just come back here. So see if I can create a new view again. So let me go back here. Just pick that one and go OK. So let me press that. See where it should. It's not playing today. Apologies for that. It was working this morning. I tried twice today. So as I say, the best interest of a presentation, things never work when you expect them to work. Anyway, I was sort of coming towards the end of today anyway, so I'll just go from current slide. So typically I would probably ask some questions. I would probably say if you email me was probably better today. Obviously, if anybody's put any questions in the chat window, we can probably get them later on. We'll probably answer those afterwards. I can see there's a few in there. I'm just struggling to see them. So we'll probably answer some of the questions. Is there a solution for using pipe support they're created on structures, but really structural components? So you could model the pipe supports as advanced steel elements if you want to. You can create. I would probably create them as a library. Someone asked that question. So there's ways inside advanced steel to actually. So when you're inside the advanced steel platform, there's a way to create what we call a standard part library. So you can come in here as a standard part template file that you would create in there. Or you could create, depending on what you wanted to do, there's a way to create custom connections as well. So it does really, so this is, so maybe you need to put the, you create this as a custom connection tool. So maybe the pipe support needs to be created as part of something else and using a particular snap point to work to. So you could build it as a custom connection and you can cross-reference it to a standard part file. It's not something I've actually done for plant because they tended to be doing it the other way around, but I was asked that question once and I showed them how to do it. I presume that company went off and did it. I think they were building, the pipe support was a big I called it a T-beam. It was a top hat beam. It had a post and a top bit on it. And obviously there's some U-bolts in it and things like that. And I did build them a sample to show that, but that is probably how I would work it out. Someone asked, is there a recording? Yes, there should be a recording. You should be sent a link to access it afterwards. So obviously by registering today, you'll get that. I'm just going to switch back to my PowerPoint. So obviously just to sort of make everyone aware, we're Graitec. We have several offices throughout the UK now. There's a couple of us in the advanced steel team based around the UK. We're not all in the south of England. And obviously we do get in the car and travel. So if you want to talk to myself or one of my colleagues, or you want to speak to Craig, who's the sale guy, and Liam, please reach out to them. Independent of this. If you've got any technical questions, if you want to come back and sort of email me, you'll probably see my email. It's obviously inside the presentation. So you could send that to me and I will try to answer your questions regarding this. As I do apologize, it didn't work today for the plant side of it on the drawings. So with that, and I'm probably going to bring today's presentation to a close. I would like to say thank you very much for everyone attending today. Thank you. So this is a continuation from the webinar we did today. I just wanted to go back and just sort of show the drawings again. So obviously I have this model open here. I wanted to create an ortho drawing. So create a new file, give it a suitable name. And obviously process that. So, and then obviously if I want to create a new view, I need to put the view in there. And I need to pick the model that I want. So I've got this one here. So obviously, and if I want to change the model selection, so if I want to come back in here and put the ladder vessel in, so So I want that included into the same project. And bearing in mind this is an advanced steel model, the other one, the structural frame is an advanced steel model, then I just click that and then obviously position it on here. It obviously processes it in the background. So once I have that in place, I can also do things like adjacent views, etc. So all this kind of stuff that it was in the so this is standard plant 3D, but that's an advanced steel model in the foreground, and obviously the plant model was slightly was on the other side of the structure. So I'm using the tool to create the drawing combined inside plant. Obviously you can move the views around, etc. So if you pick it up, you can move it around on the drawing. You can obviously change, I expect you can change the size of it as well if you want to, so you can reduce the size of the view that's available. So that was the idea of what I was trying to show in the presentation this morning, and it just wasn't playing ball with me this morning for some reason. As soon as I came out of the GoToMeeting interface, it worked perfectly fine. So apologies for that this morning. Hopefully that reassures you that you can do a combined drawing inside Plant 3D using the advanced steel model as well as the plant objects as well. Thank you.